Welcome back, everyone. Today we're going to be looking at the behavior of how linear functions behave versus exponential functions. Okay, and so let's just compare what happens when we're dealing with linear functions versus exponential functions. So with linear functions, remember we have a constant rate of change. So if we start at our point, let's start at our y-intercept, which is in this case 0, 0. Our constant rate of change is going to be 1 because we move to the right 1 and up 1, to the right 1 and up 1 to get to the next point. Or it would be down 1 and left 1, down 1 and left 1. Okay, in exponential functions, remember that our common ratio, or our value of b, is the ratio of the successive output values. So this causes our equation or our function to increase drastically depending on the value of that common ratio. All right, so let's take a look at an example of a linear versus an exponential function. All right, so we want to compare the two salary plans that we have listed here, for job A and job B. And we want to find out, will job B ever have a higher monthly salary than job A? If so, after how many months will this occur? Okay, so job A, we're earning $1,000 for the first month with a $100 pay raise every month thereafter. And then for job B, we're earning $1,000 for the first month with a 1% pay raise every month thereafter. Okay, so what we're going to do is let's just look at, for the first 3 months, how how our pay rate is increasing. Okay, so for job A and job B, for 0 months, which is just basically when we first get this $1,000 increase, it's just going to be $1,000. Okay, and for job A, after 1 month, we get a $100 raise, so we're going to have $1,100. After 2 months, it'll be $1,200, and 3 months will be $1,300. Okay, now for job B, it's going to be a little different because we're no longer getting a $100 raise. Now we're getting a 1% raise. So we have to take 1% of this $1,000 and add that to the $1,000 to get what we would earn for after the first month. Okay, and that's actually going to be a value of $1,000 and $1,010. Okay, and then for month after the second month, we'll have $1,020.10, and then after the third month, we'll have $1,030.20. Okay. So looking at these values, we see that job A, we actually earn a higher amount of money every month based on the $100 raise every month versus job B. Okay, but what if we wanted to find out after, let's say, 200 months? We wouldn't want to sit here and fill in this chart for 200 months. But we know how to find equations for these functions, right? So we know that there is a constant rate of change of $100 between each value. So we know that the first equation is linear, all right? And so let's come up with a function for that. We're going to call that salary of job A, which is going to be our y-intercept, which is 1,000, or our initial value of 1,000. And we're increasing by $100 every month. Okay, so we get the equation 1,000 plus 100x. Now for job B, which would be S of B, we're going to have a salary of, now we're increasing by a percentage. So if you remember, this is similar, and it's exactly like exponential growth, right? So we're going to have our initial value times the 1 plus our percentage, which we changed to a decimal, so it's going to be 0.01 raised to the x. And this will give us the amount earned after every month. Okay, and so let's collect our terms. So we get 1.01 raised to the x. All right, and so we want to find out when they asked us to find out, will job B ever have a higher monthly salary than job A? Okay, so what we're going to do is we're going to grab our calculator and we're going to graph these, and let's see what happens as we increase the value of increase the number of months. All right, so let's graph these equations. All right, so remember to clear out your calculator, second mem 712, which I've already done, and then we're just going to graph these. So let's go to our y equals 2 so we can put them in. So we have 1,000, y1 is going to be 1,000 plus 100x. Okay, and enter. And then y2 is going to be 1,000 times 1.01 raised to the x. And press enter. And so now we want to graph these two functions. And so we see that we need to change our window. Okay, so we've changed our window value so that we can actually see our graph. So I want my x-min to be 0, my x-max to be 400, my y-min to be 0, and my y-max, I want my values somewhere around 40,000. Okay, and so once we change our window, let's hit graph, and you see that we get the graph of the two functions. All right, and so we want to find out when job B's salary will be higher than job A's. So we want to find the intersection of these two so that we know when they're the same, and then right after that, hopefully job B will be higher than job A. All right, so remember to find the intersection of these two functions, we're going to hit second trace, which gives us the calculate menu, and then we want option 5 to find the intersection. They're gonna ask you your first curve, you press enter, your second curve, and then a guess. So you want to put your cursor close to where you think the intersection is going to be, which we see is going to be right around here, and press enter, and then it's going to give us the actual intersection. Okay, and we see that our intersection is 363.96, which is roughly or approximately 364. So we know that after at 364 months, these two salaries will be equal. All right, so now let's look. We can also find this out from our table. So let's check our table of values. So we're going to go to second graph and look at the table. Okay, and we want to start around that value of 364, right? So when you pull up your table in your calculators, it's going to start from your beginning values of 0. In order to change the values that you want to go to, we're going to go to second window, which is the table setup menu. And if you notice, we have table start where we want to start our table. So here you're going to put in that value. Let's use 355 because that's a little bit low, 364, and then we can just scroll through our values to see to find the information that we need to find. Okay, so you're going to input that value of 355, and then you're going to go back to your table, and it will give you the values that you need starting from 355. So we know that our two graphs intersect at 364 months. So let's scroll down to 364. And we see that actually at 364 months, this is when job B offers a higher salary than job A. So at approximately 364 months, job B will have a higher salary. Okay, and so let's scroll up and let's make sure that we answered all the questions. Okay, and so yes, if so, after how many months will this occur? And so after 364 months, job B will have a higher salary than job A. Okay. All right, and so finally, a gas had an initial pressure of 150 torr. Its pressure was then measured every 5 seconds for 25 seconds. Determine whether the change in pressure over time is best described by an increasing or decreasing function, and whether it is linear or exponential. Okay, and then we want to find a regression equation for this information. All right, so the first thing we're going to do is we're given this table of data, and we want to, as the time increases, the pressure, it looks like, is decreasing, because we go from 150 to 117 to 90 to 70, 56, and then finally 41. So we know this is a decreasing function. Okay, and now we want to figure out whether it is linear or exponential. So to determine whether it's linear, remember we look for a constant rate of change. So if we look at the values, our y values, we see that between 0 and 5 seconds, that it decreases by 33 torr. Okay, so if this is going to be, we're going to make a table for the difference. And then we want to find, if it's exponential, we look for a common ratio. So let's look for our common ratio in this column of the table. Okay, so the difference here is -33. Okay, and then from 117 to 90, we're actually going to have a difference of 27. From 90 to 70 is a difference of 20. And then we have a difference of 14 and a difference of 15. So if we notice, we know this is not linear because our differences between our sets of y values is not constant. It's constantly changing. We go from 33 to 27 to 20 to 14 to 15. But if we look at our common ratios, between the first two sets of successive values, we get a common ratio of 0.78. And if we find the ratio between the second two, we get 0.77. Okay, and then the third one is 0.78. And then we get 0.80 and 0.73. So even though our common ratio is not exactly the same each time, they're very close together. So we know that we expect this function to behave exponentially. Okay, and so what we want to do now is we want to find a regression equation for this exponential function. So we're going to go into our calculator and we're going to do that. Okay, so let's grab our calculator. And again, we want to reset our memory. Okay, so second mem 712 and enter. And then we're going to go to, we're going to again use our stat. So we're going to edit and we're going to input our list. So we have 0, 5, 10, 15, 20, and 25. Okay, and then we're going to scroll over to our list 2, and we're going to input our y values of 150, 117, 90, 70, 56, and finally 41. Okay, so we've inputted our values into our, and we've made our list, and now we want to find the exponential regression function. Okay, so remember, to do that, first we need to go to back to stat, and then we want to calculate, and we want to choose choice 0, right, which is the exponential regression. Okay. And so when we do that, in the previous example, we stored our regression. We don't need to do that now because we're not actually doing a scatter plot and fitting this line to that this curve to that scatter plot. We're just calculating the regression equation. So we're just going to hit enter, 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 and calculate. And so we see we get a regression equation of 151, because we're going to round to the nearest whole number. And then for a value of b, we get 0.95. Okay, so our equation is going to be 151 times 0.95 raised to the x. Okay, and so for this particular set of data, we get an exponential regression equation of y, y equal to 151 times 0.95 raised to the x. Okay, so that is the end of today's lesson.